Hello everyone. In this video, we will talk about estimation and prediction in simple linear regression. So by estimation, we mean the confidence intervals on the parameters, and by prediction, we mean the prediction intervals. So what we do is, remember the distinction between the prediction interval and the confidence interval, the prediction interval and the confidence interval. Okay, the distinction between them. So confidence interval was about finding an interval for a parameter mu. Okay, so mu was the parameter for the average of the population. The prediction interval was for a single observation. Okay, was for a single observation. So what we say here is that we just predict, right, a single or individual y value, for example, say y0 for any given x0. So remember, here I have a linear regression where I can write mu y given x0 is equal to beta 0 plus beta 1 times x, right? So for, let me just write x0 here. So this means you can find a mu value at a given value of x. Okay, so somebody should give you an x in order to find a mean value. Okay, so if nobody gives you x, then you cannot find any value. So we just predict a single value, okay, and we estimate the average y value, a parameter denoted by mu y, okay, again, in fact, for a given x0, okay, for a given x0. So the average y value of parameter, that's a parameter, right? Mu y, or equivalently mu y given at some mu y given some x0 value, okay, for a given x0. So let's y0 hat be the value associated with that x0. That's y0 hat is equal to b0 plus b1 times x0. Okay? So x0 is given, it's some value. For example, it's the height of a person. Let's say it's 180 centimeters. What is b0 and b1? Remember, b0 and b1 are random variables, right? Hence, y0 hat is a random variable itself. Okay. So what I want to do is I want to find its mean value and its variance to construct confidence interval on its mean. Okay. Remember, we say x bar was a random variable. Okay. It was normal. It was normal, right? With some mean mu and with some x sigma divided by root n. And then using the distribution of x bar, I found the confidence interval on mu, right? So I will do exactly the same thing here. So I will try to find the expected value of y0, expected value of, sorry, y0 hat, right? Y0 hat. And then construct the confidence interval on this expected value using the distribution of y0 hat. Well, one can show that expected value of y0 hat is equal to mu y, right? So expected value of y0 hat is equal to mu y, or remember this mu y is beta 0 plus beta 1 x0. And it can be also shown that I won't get into the details, but its variance is equal to sigma squared times 1 over n plus x0 plus x bar squared divided by sxx, right? So then well, again, one can show that this y0 hat minus its expected value divided by its estimated standard deviation, right? Okay, so this is what y0 hat minus mu of y0 hat divided by s of y0 hat, right? This is t distributed with n minus 2 degrees of freedom. And from here, what I do is I just construct a confidence interval on mu of y0 hat. Okay, so mu of y0 hat is between this quantity and this quantity, and practically is very much the same with the other confidence intervals. It's somehow x bar plus minus t alpha over 2 times s of x bar, right? So most of the time, you don't need to make this by your hand. You have some computer outputs and you can just check them. So let's make an example here. Well, let's use the ALICE data, okay, to construct a 95% confidence limits for the mean response mu y. Okay? So what I will do is I will try to find the confidence limit or confidence interval for mu y, okay, when x0 is equal to 20%. So what I'll try to do is find a confidence interval, okay, on the mean response, on the average response, on the mean response, okay, on the mean response, when x0 is equal to 20%. Okay, so what does this mean? Just find a confidence interval on the mean ALES scores of students whose GPA is at 20%. Okay, so let's find the estimated value of the mean response. That is, the analogy is x bar. Just find the x bar at this x0 value. Just plug it there. 3.83, remember, plus 0.904 times 20. That's equal to 21.9. So that's the x bar, okay, of the x bar of what? Students whose GPA is 20%, okay, 20%. So this is the x bar of ALES scores of students, right? ALES scores of students whose GPA is 20%, okay? So in the previous slide, we just calculated the x bar, SXX, the S, T sub 0.025 for n minus 2 degrees of freedom, which is, remember, n minus 33, right? And S of y hat, that was equal to, no, we didn't calculate, but we can just calculate it now. How? Just go back to the formula there, right? This is the S of y hat, S sub y 0 hat. So 1 over n is 1 over 33. X0 is 20 minus x bar. I don't remember the x bar, but we can just write it there. Divided by SXX, right? So let me, if I'm not wrong, S times 1 over n plus x0 minus x bar squared divided by SXX, right? So x0 is 20, x bar is just there, SXX is here, 1 over n is 1 over 33, and s is given there. If you just plug in the values, then the standard deviation at the sample standard deviation, the estimated standard deviation at this y value. So again, what does this mean? This is the standard deviation of, ALES scores, okay? ALES scores, this not standard deviation, but estimated, let's say, okay? The estimated standard deviation of ALES scores of students, right? Whose GPA is 20%. Right? So a 95% confidence interval for the guys whose GPA is 20% is this, okay? So I am 95% sure that the students whose GPA is 20%, if they get into the ALES, then they will have some scores from ALES, right? Then the average of these scores, again, the average of these scores is between 20.1 and 23.7. Okay, so this is a confidence interval. It stands for the estimate of. It stands for the average of the scores. Okay, for the mean of the scores. So, well, what you can do is, well, these are the data, right? These blue points are the data. These are data, right? And this middle line, this line is the estimated regression line. This line and this line. So this is the upper confidence interval, okay? Upper confidence interval, and this is the lower confidence interval. Okay, so if you just plug in the confidence interval, you can see that, well, so it's almost a parallel line to the regression line, both of them. Upper confidence interval is at the upper part and lower one is just beneath the line. One thing to just be careful here is that, well, the distance here, okay, the confidence interval here is narrower than the confidence interval here, right? That's because, well, just go back to the confidence interval formula. Just look at here, right? So this confidence interval becomes large and large if your x0 just gets away from the x bar, okay? So just around the x bar, the confidence interval is very narrow. If you get away from where? If you get away from the average, then your confidence interval becomes just wider, right? So this is just like, again, a tahterevalli, right? Just like this. So as you see, the movement here is just restricted when you just compare it with the movement there and movement there, right? So the confidence interval here is narrower than the confidence interval at the extremes, okay, at the both extremes. Okay, so the next thing is the prediction interval, okay? So as we said, the prediction interval is for a future observed response, okay? That's just for a single response. So confidence interval was for the parameter mu, okay? So remember, well, I have a distribution like this, okay? The center of the distribution, it's mu, right? And the confidence interval says the confidence interval is about this mu, okay? So I just give an interval, okay, and say that, well, your real mu should be with 95% between this and this point, okay? Well, the prediction interval just stands for a single observation or single response, okay? So what does it mean? It says with 95%, your observation can be, let's say, between this and this value, okay? So it's for a single observation again. Okay, so without getting again into the details, well, remember our confidence interval was something like this: y0 hat plus minus t alpha over 2 times s, right? 1 over n plus x0 minus x bar squared divided by sxx, okay? So remember what we were doing in finding the prediction intervals, okay? We were just adding a 1 plus into the square root, right? We just do the same thing here. We just put a 1 plus here, and this is my prediction interval, okay? Okay, this is my prediction interval. Then let's make an example again. Okay, so here what I do is I just plot the prediction interval on the same plot, okay? So as you see, this line, okay, this line, and this line are the confidence intervals. The line at the outer side, okay, this line and this line are for the prediction intervals, okay? So as you might see, the prediction intervals, which is for a single observation, is just wider than the confidence interval. So this is the confidence interval and prediction interval outputs in Minitab, okay? So for the first observation, the fit is 6.541. This is y hat, this is y hat 1, y1 hat. What is this? This is the point on the line. This is the estimation, this is the estimator, this is the point estimator of the first observation, okay? I forget the first observation. Let me just go back if I have the data there or not. Okay, here I don't have the data. So, okay. So the first data was 3, okay? The GPA is 3. and the real value was 5. So its R score was 5%, right? And the fit here, the fit given by the line is 6.541. And this is the standard error of the fit. So what is the standard error? Remember, it's something like S times 1 over n, right, plus x 0 minus x bar squared divided by sxx. And this is the confidence interval where you just write y1 hat plus minus this s, right? And this is the prediction interval where you just write y1 hat plus minus t alpha over 2 times what? Times 1 plus 1 over n plus x0 minus x bar squared divided by sxx. Okay. So we have the same thing in R. You can just calculate this in R with this keywords, and you will just make an example. In fact, the same example in the recitation with Doruk. Okay, so if you just so these are the fitted values. These are the y1 hats, yi hat values. Okay, this is the lower confidence interval, and this is the upper confidence interval, right? And this is the lower prediction interval, and this is the upper prediction interval. So as you see, 3.2231. Just look at here. This is the 3.2231, 9.8580. So just go up. Well, they are the same. 3.223, 9.858, right? And so minus 0.8343, minus 0.8343, they are the same, right? Okay, so you can just find this confidence intervals and prediction intervals in all of the sort pairs, and now you know how to calculate these confidence intervals and prediction intervals.